All right, moving on now to graphical representations of the data. A pie chart is appropriate graphical representation for either nominal or an ordinal variable. It's more appropriate when we're dealing with a nominal variable because um, we want to just know the percent or a visual representation of how many in what category we have. So here I have kind of basic costs for a business. We have food and beverage costs, labor administration and benefits cost, rent and debt service cost. This is kind of how to articulate the budget expenditures for a company. So in each one of these little pieces of the pie is a certain percentage of amounts paid for this particular type of expense. Now, bar graphs are meant to present information across a nominal level of variables. So, for example, across the graph down here, I have years 1977, 1982, 1987, 1992, 1997. Okay, so this is not an interval scale because these refer to different years. These are ordinal categories. They refer to years of time. And this is the number of women-owned firms that we see. And so we can see that across this bar graph, we have the rates of women-owned firms increasing significantly from 1977 to 1997. So across this 20-year period, we see quite a significant increase of women-owned firms from about 12,000, it looks like, to a little over 80,000. Now, histograms look like bar graphs, but with one major difference. The x-axis of a frequency histogram is continuous, not categorical. So we can see that these bars exist between the levels of the independent variable in a bar graph. There are no such spaces in between the bars in a histogram because the bars in a histogram refer to frequencies of continuous data. Frequency polygon is a way to kind of turn a histogram into a line graph. It represents, again, the relationship between frequency and levels along a continuous x variable. So we can see here that we have at 17 minutes relatively few. We have a little dip, we have a little bump at 19 minutes, and then a dip at 21 minutes. And then there's something about 23 minutes that creates a pretty dramatic increase. So this kind of allows us to look at trends in the data. And then a line graph is going to assess change over time. So here we have units of time across the x-axis here, and we have some sort of numeric index over here. So this lets us look to see over time, are there increases in sales? Are there decreases in sales? And this type of information is very digestible and very easy to understand in a graph, whereas if you just put the frequencies in a table according to years, I mean, people can recognize the fact that there's an increase or a decrease, but putting it in a line graph is in a format that's more profound, and so it's easier to kind of pop what the message is. So if you were looking at sales, if this was a measure of sales, we could see we might want to target our marketing mechanism in about April, because in May we have the highest amount of sales in this half of the year, and in November we have another bump. This might be because of Christmas sales. So it's nice to know where you have peaks in your data.